Then, hello everyone. I'm so glad that everyone could make it again this week. My name is Flora. I'm one of the organizers of these Postgres Extension Ecosystem Mini Summits, which is a series of free and online mini summits leading up to the session at the Postgres Development Conference this May or next week in Montreal. The other organizers are David from Tembo, Yuri from Omnigress, and Keith from Crunchy Data. This stream and the closed captions that we'll provide with it sometime next week. The captions will be ready, I promise. They are supported by pgconf.dev and their gold level sponsors, Google, AWS, Huawei, Microsoft, and my employer, EDB. So today we have is the last in our series. We have Gabriele to talk to us about improving the Postgres extensions experience in Kubernetes with CloudNativePg. That is a last minute title change just to keep us on our toes, I guess. So Gabriele is the VP of Cloud Native at EDB and a Postgres contributor. He's a maintainer of CloudNativePg and was once almost a pro football player. He doesn't want to talk about that though. He's also a lifelong musician and works with the CNCF on the de facto Kubernetes operator for Postgres right now. So Gabriele, when you're ready to share
Yeah,
your screen, I will stop sharing and the floor is
I've
all
got the
yours.
same shirt, the same T-shirt as in your picture. That's
Yeah, we know. Yeah, we didn't even discuss it. Go
it
figure.
does.
That's just how connected we are.
Yeah. Hi, everyone. Okay, so thanks for this opportunity. So thanks, thank you, Flora and David, primarily for inviting me today. And I normally start with a question every presentation I have. And this is actually the question that has been hitting me and the other maintainers of CloudNativePG, and some are in this call from the first day. Okay. We know that how extensions are important in Kubernetes, in Postgres. And we've always been asking, how can we deploy extensions without breaking the immutability of the container? So today I will be telling basically our story and hopefully providing good insights in the future about how with CloudNativePG we are trying to improve the experience of Postgres extensions when running databases in Kubernetes. So as Flora mentioned briefly, I'm a VP and Chief Architect of Kubernetes at EDB. I've been using Postgres for 25 years. I'm one of the co-founders of Second Quadrant, which was bought by EDB in 2020. And because of my contributions, I've been recognized as a Postgres contributor, and I'm really grateful for that. And I'm also Data on Kubernetes ambassador. So my role is to promote the usage of stateful workloads in Kubernetes. And I'm also DevOps evangelist. I always say this, DevOps is the reason why I encountered Kubernetes, and it will also be the reason why I move away one day from Kubernetes. Okay. So it's about culture, and I'll explain this later. And in the past, I've been working with Barman. I'm one of the creators of Barman, and since 2022, I'm one of the maintainers of CloudNativePG. So I want to thank EDB. My company. EDB is the major contributor in Postgres history, okay, in terms of source code, okay. And right now we are also the creators of CloudNativePG, and as we'll see, the company donated the IP to the CNCF. So it's something that is quite rare, and I'm really grateful for that. So what I plan to cover tonight is first, set the context, then talk about immutable application containers, which have been kind of a dogma for us from day one. Then how we are handling right now extensions in Kubernetes with CMPG, but this is quite similar with the way other operators deal with it. Then the future and the key takeaways. So first, we're talking about Kubernetes. I mean, if you're not familiar, I mean, it's an orchestration system for Kubernetes. What I always say is that it's not just an executor of containers, but it's a more complex system that also manages infrastructure. So when it manages infrastructure, it also manages the cloud native applications that are also called workloads. And when we're thinking about Postgres in Kubernetes, a database is a workload like the others. That's, I think, the most important mind shift of Postgres users. I mean, that I have faced myself, that I've always treated Postgres differently from the rest. Here in Kubernetes, it's just another workload. Then, of course, it's not like any other workload, and that's where operators come into play. And I think the work that we are doing even tonight is in the direction to improve how databases run in Kubernetes in general and for everyone. So it was open sourced in 2014, and it's owned by the CNCF, and it's actually the first project that became graduated. And graduated is the most advanced stage in the graduation process of the CNCF that starts with sandbox, then incubation, and then graduation. Okay. So then CloudNativePg is an operator for Postgres, and it's production ready. What we say level 5. Level 5 is kind of a utopic and unbounded level. It's the highest one, okay, and it's defined by the operator development framework, and it's used by all these players, including Tembo, IBM Cloud Pak, Google Cloud, Azure, Akamai, and so on. As I was mentioning before, when I mentioned the sandbox, CNCF, CMPG is a CNCF project since January. It's distributed under Apache License 2.0, and the IP, the intellectual property, is owned by the community and protected by the CNCF. Therefore, it's a vendor-neutral and openly governed project, and this is kind of a guarantee that it will always be free. This is also, in my opinion, a differentiation between CloudNativePg and the rest. And the project was originally created by EDB, but specifically at that time by Second Quadrant. And as I always like to recall, it was Simon Riggs that put me in charge of that initiative, and I'll always be grateful to Simon, not only for that, but for everything he's done for me and the team. So CMPG can be installed in several ways, and as you can see, it's very popular in terms of stars. There's more than 4,000 commits, and what's impressive is the number of downloads in 3 years, which is 78 million, which means that it's used the way we wanted it to be used, therefore with pipelines, CI/CD pipelines. This is the CNCF landscape. These are the CNCF projects, and as you can see, there's only 5 projects in the CNCF in the database area, and CloudNativePg is the only one for Postgres. And our aim for 25 and 26 is to become incubating. Okay, so if you're using CloudNativePg and you want to help with the process, get in touch with me and Flor to help us, reach that stage, essentially.
Gabriele, do you want to answer questions as you go along or save them for the end?
Yes, sorry, what's the question? I can't
Boots.
see.
Somebody raised their hand.
Sorry, I
Okay.
don't see the question. Sorry, if you can
The
read
hand
it.
the hand went down, so I
Okay,
think we're
now I
good.
can. Okay. Okay, misclick. Okay, good. Okay, so I think to understand again why we've done all this process that led to the patch that you see in Postgres 18, it's important to understand what cloud native has meant to us since we started in 2019. We've got kind of our own definition, but I think it still applies. So for us, it's three things: cloud native. It's people and people that work in a following DevOps culture. And for example, there are some capabilities that come from DevOps that apply to the cloud native world, and I selected some of them, like immutable infrastructure, infrastructure abstraction, version control. Primarily, these three form the infrastructure as code, principle, okay, together with declarative configuration. Then, shift left on security, you'll see the CloudNativePg, we rarely mention security because it's pretty much everywhere. Okay, it's part of the process. Okay, then continuous delivery. Then the second item is immutable application containers, which kind of led to the immutable way of thinking extensions. Okay, and then the third one is that these application containers must be orchestrated via infrastructure as code by an orchestrator, and the standard right now is Kubernetes. So for us, it's these three things, and without any of them, you cannot achieve cloud native. So, but what are these immutable application containers? To explain immutability, I like to talk about the mutable infrastructure, which is probably what the majority of people that have historically worked with Postgres are used to. Okay, so primarily referring to traditional environments like VMs and bare metal, where the main way to deploy Postgres is through packages, maybe even managed by configuration managers, but still packages are the main artifacts. And the infrastructure is seen as a long-term kind of project, and changes happen over time and are incremental updates on an existing infrastructure. So if you want to know the history of the infrastructure over time, you need to check all the changes that have applied. So and in case of failure of a system, systems are healed. So that's the PETS kind of concept that comes from DevOps. On the other hand, immutable infrastructure relies on OCI container images. OCI is a standard. It's the Open Container Initiative, and it's part of the Linux Foundation as well. And immutable infrastructure is founded on continuous delivery, and which is the foundation also of GitOps practices. Okay, in an immutable infrastructure, releasing a new version of an application, for example, is not updating the system's application. It's building a new image and publish it on a public registry and then deploy it. Okay, and changes in the system happen in an atomic way. So the new version of a container is pulled from the registry, and the existing image is kind of almost instantaneously replaced by the new one. This is true for stateless applications, and we'll see, in the case of stateful applications like Postgres, is not that instantaneous because we need to perform a switchover or restart, in any case, generate a downtime. So when it comes to Kubernetes, the choice was kind of obvious, was to go towards the immutable infrastructure. So no incremental updates. And in the case of stateful workloads, where you cannot change the content of the container, you can use data volumes or persistent volumes. These containers are not changed. So if you want to change even a single file or a binary in a container image, you need to create a new one. So this is very important for security and change management policies in general. But what I really like about this way of managing our infrastructure is that at any time, Kubernetes knows exactly what software is running in your infrastructure. Okay, and all of this is versioned in a SCM, like Git or whatever. This is something that in the immutable world is less easy to obtain. Okay. Again, for security, this is the foundational thing, because this is how you can control CVEs, the vulnerabilities in your system. This is a very basic representation of how you build let's say the life cycle of a container image. You create a Docker file, you put it in Git, for example. Then there's an action or there's a pipeline that creates the container image, maybe even runs some tests, and then pushes it in the container registry. So I walked you through the concepts of mutable and immutable containers. What are these immutable application containers? So these have been, if you even go back and read, what we were writing before CloudNativePg was famous, so we was, even used, we were always putting immutable application containers as one of the principles we could not lose. Okay. So it's just a couple of things. So an immutable application container, it means that there's only a single application running. So that's why it's called application. If you have been using Docker, you're more familiar with system containers. So you run a Debian system, you just connect and then you start treating it like a VM. Okay, application containers are not like that. For example, and then they are immutable, so they're read-only, so you cannot even make any change or perform updates of packages. But in CloudNativePg, because we are managing databases, we need to put the database files in separate persistent volumes. Persistent volumes are standard resources provided by Kubernetes. And this is where we put PG data. And if you want, a separate volume for all files with different even storage specifications, and even an optional number of table spaces. And CloudNativePg orchestrates what we call operand images. These are very important to understand, that contain the Postgres binaries. And they are orchestrated via what we call the instance manager. The instance manager is just the process that runs and controls Postgres, is the PID1 or the entry point of the container. So there's no other, like SSHD or other, syslog, other applications working. Okay, so there's just the instance manager that then controls everything else. And this is the project of the operand images. So this is, again, one open source project. And every week, I think we rebuild the Postgres containers. And we recently made some changes to the flavors of these images, and I'll talk about shortly. So we mentioned the database, we mentioned the binaries, but what about extensions? Okay, so this is the problem. So Postgres extensions in Kubernetes with CloudNativePg is the next section, and it's kind of a drama. Okay, I'm not hiding this. Okay, so the way we are managing extensions in Kubernetes right now, in my opinion, is not enough. Okay, it works, but it's got several limitations, and I'm going to the mostly, limitations in terms of usage. Okay, sorry, I think, yeah, okay. So, so if we want to place them, for example, we cannot place them in the data files, okay, or in persistent volumes, because these volumes are not read-only, or in any way. In any case, they cannot be strictly mutable, okay, immutable. So we discarded this option to have, you know, persistent volume where you could kind of deploy extensions, and maybe you can even download on the fly or use, you know, the package manager to download them, or this kind of operation. So we discarded this from the start, and we kind of embraced the operand image solution. So essentially what we did was placing these extensions in the same operand image that contains the Postgres binaries. This is a typical approach of also the other operators. If you think about also Zalando, we call it the spillaway. Spilo contained all the software that would run with the Zalando operator, okay? Our approach was a bit different, that we didn't want to have, we wanted lighter images. So we kind of created a few flavors of images. And we also selected some extensions that we placed in the images that we provided. But in general, we recommended to build custom images. So we provided instructions, and we've also provided the requirements to build container images. But as you can see, the complexity at the operational layer is quite high. So and it's not reasonable to ask any user or any customer to build their own images. And this is how they look now, although this is changing, as I was saying. So you've got a base image, for example, a Debian base image, you deploy the Postgres binaries. Then even right now, although it's changing, CloudNativePg requires Barman Cloud to be installed. And then we install the extensions that we think are kind of needed, okay? For example, I think we distribute PG audit, if I recall correctly, PG vector and PG failover slots. So every layer you add, of course, the image is heavier, and we still rely on packages for most extensions. So the problem is you've got a cluster that is already running, and you want, for example, to test an extension that's just come out, and or you want to even deploy it in production. If that extension is not part of the images that we build, you have to build your own image, okay? And because of the combinations of extensions possible combinations that exist, it's impossible to build all of these combinations. You could build, for example, a system that allows you to select what extensions you want and then build the image, but in our way of thinking, this was not the right approach. Okay, and then you've got system dependencies, and if an extension brings a vulnerability that affects the whole image itself and requires more updates, not just of the cluster, but also of the builds of the images. So we wanted to do something else, but we immediately faced some limitations of the technologies. Okay, bigger one was on Postgres. The other one was on Kubernetes. So in Postgres, extensions needed to be placed, still in 17 to be placed in a single folder. So it's not possible to define multiple locations, but thanks to the work that Peter and his team have done, now we've got extension control path in version 18. And Kubernetes could not allow until 10 days ago to mount OCI artifacts as read-only volumes. So there's a new feature that is now part of Kubernetes 1.33 that allows us to do it. Okay, so this is the patch that I was talking about, Postgres by Peter Eisentraut, and I'm really happy that CloudNativePg is mentioned as one of the use cases. And there's also, mention for the work that me, David, and Marco, and primarily Marco and Niccolò for CloudNativePg have done. So thanks for this. And this is the patch that introduced volume source in Kubernetes 133. So the future, the idea is that with Postgres 18, now we can set in the configuration where we can look up for extensions in the file system. And then if there are libraries, we can also use the existing dynamic library path GAC for managing this. So you remember, this is where we come from, this one. The good thing is that now we have this opportunity to build Postgres images that are minimal, that only contain Postgres. So instead of recreating them every week, because it's very likely that something, some dependency has a CVE, and so recreate them for everyone. So forcing everyone to update their Postgres systems, we can now release them maybe once a month and follow pretty much the Postgres cadence of release for patch releases, and maybe if there are CVEs, release more frequently. The other good thing is that now we are working to remove the in-core dependency on Barman Cloud for CloudNativePg. So CloudNativePg has a new plugin interface, and we are in 126, which is expected in the next weeks. We are suggesting people to start moving for new workloads to the Barman Cloud plugin solution. What happens is that Barman Cloud will be in that sidecar image. Okay, so it will be distributed separately, and so its life cycle is independent from the one of the rest. But the biggest advantage is that any extension in Postgres can be distributed. Right now we've got packages. The idea is that they are distributed also as images. Okay, so if we start thinking about this approach, so if I write an extension for Postgres, and until now I've been building only packages for Debian or for RPM systems. If I start thinking about also building container images, they could be immediately used by the new way of CloudNativePg to manage extensions. So that's my ultimate goal, let's put it that way. So this is how things will change at runtime without breaking immutability. So there will be no more need to think about all the possible combinations of extensions. So there will be, the Postgres pod that runs, for example, a primary or standby, that will have the container for Postgres. If you're using Barman Cloud, the sidecar container managed by the plugin with Barman Cloud. And then if you've got any extension, for every extension you have, you will have a different image volume that is read-only, very light, only containing the files distributed in the container image of the extension. And that's all. So once you've got these, we can then coordinate the settings for external extension control path and dynamic library path. So what we did was starting a fail-fast pilot project within EDB to test the work that Peter was doing and on the extension control path. And for that, we used the Postgres Trunk Containers project, which is a very interesting project that we have at CloudNativePg. Every day it rebuilds the latest snapshot of the master branch of Postgres so that we are able to catch at an early stage problems with the new version of Postgres in CloudNativePg. But there's also an action that builds container images for a specific, for example, commit fast patch. So we use that. And Niccolò wrote a pilot patch, exploratory patch for the operator to define the extensions stanza inside the cluster resource. And he also built some bare container images for a few extensions, and we made sure to include a very simple one and the most complex one, which is PostGIS. So this is the patch that we, it's still a draft, and we're planning to, the idea is to have it in the next version of, 1.27 for CloudNativePg. And this is how it works. So we have the extensions, section in the cluster definition. We name the extension. Theoretically, we could also define the version, and we point to the image. What's missing in this pilot patch is also support for image catalogs, but that's something else, that we can worry about later. So what happens under the hood is that when you update or when you add a new extension in the cluster definition, a rolling update is initiated. So there's this short downtime, but the container image is loaded in, the replicas first and then in the primary. And an image volume is mounted for each extension in the, let's say, /extensions name of the extension folder. And CMPG updates, these two parameters. So it's quite clean, quite neat. It works, but most of the work needs to happen here. So, that's been my call. To call container images as a first-class artifacts. Okay, so if these changes, we have a new way to distribute images. Okay, so just to approach the conclusion, if you want to know more about the whole story, I wrote this blog article that recaps everything. And the key takeaway for me, and then we go more on the patch, if you want to, and then I'll also address the questions. But what is important for me, and having been in the Postgres community for a long time, there's I think this is a good moment for us to challenge the what I call the status quo of the Postgres extension distribution and ecosystem. Okay, so I think we have an opportunity now to define a standard, which I just want to be clear. I'm focusing myself primarily on CMPG, but this is in general, even for other operators. I'm sure that this will benefit everyone, and overall, it will reduce the waste that we collectively create when distributing these extensions in Kubernetes. Okay, so if this becomes a standard way to distribute extensions, the benefits will be much better operational work for everyone. Primarily also easier testing and validation of extensions. Right now, if you see an extension, ideally that extension, and it's very easy to build, if you are in GitHub, to build the container images. GitHub, for example, already provides the whole infrastructure for you to easily build container images. Okay, so if we find a standard way to define kind of a GitHub action to build Postgres extensions, I think if you are a developer of an extension, you can just use it, and then you find a registry in your project directly that continuously publishes or periodically publishes these extensions. So if any user can just reference that image URL, and then without having to build images, they're just one, let's say, rolling update away from testing a patch, testing also the upgrade paths. I think there are some known unknowns that kind of scare me in general, about upgrades of extensions. Okay, so this is, in my opinion, one of the biggest issues that it's not that they're not solved, but they require more attention and more testing if you're using them in an immutable world. All of these will, in my opinion, will be much better with this with the approach that we propose. Images will be lighter, and the lighter image is also safer and more secure, so less prone to have CVEs and less prone to require frequent updates, and also they reduce the usage of bandwidth for an organization in general. And what I was saying before, if you are any extension project can be fully independent, so have their own way to build images and publish them. And then one last point, I keep hearing many times, that all of the stuff that we are proposing right now, it seems like a kind of a limitation of Kubernetes for Postgres. The way I see it, in my view, is that it's not actually a limitation. Is that these problems have never been addressed before. Okay, so when we think that the biggest mistake we can do is focus on the specific problem of managing extensions without analyzing the benefits that the entire stack brings to an organization. Okay, so Kubernetes brings a lot of benefits in terms of security, velocity, and change management and operations that any organization must consider right now. So any Postgres DBA, any Postgres user, my advice is to, if you haven't done it yet, start taking Kubernetes seriously. Okay, and so I don't know. We have questions. I don't know how to. Okay.
Awesome, thank you. There was a lot of chat. There was a lot of chatter, so you might need to scroll up a little bit. I do think that David, you wanted to talk maybe a little bit about mutable volume pattern, or you don't want to talk about it. I don't know if which of the two.
Well, if people are interested, those in your early slide where you were looking at alternatives, one you were thinking of was putting extensions on immutable volume, and you decided not to do that. But at Tembo, we did do that. And I did a bunch of work on trying to improve that and try to minimize like image size and all that in the last couple months. Tembo Cloud is shutting down now, so that I stopped before I finished it, but I made quite a bit of progress. I'm happy to kind of talk through the ideas there. But I think that this approach is a better long-term solution, fundamentally.
So, and I mean, I would like actually, if another point, if Marco and Nicolò, if you want to talk about the actual work you've done, before, let me reply to Peter. So, Peter, it requires a downtime because at the moment when you add the new image.
Gabriele, can you maybe like repeat the question because
sorry,
you won't see the chat in the recording.
You're right. Yeah, that's fair. So Peter asks, why does an installation of an extension require a small downtime? So I'm actually trying to find the slide where I put that. So the reason is that at the moment, the image volume patch, here it is. If you add a new image volume, it requires the pod to restart. Maybe, I don't know, Nicola or Marco, if you want. Jonathan, I see there's also Jonathan, if you want to correct me on that, but
it requires a rolling update of the cluster right now.
So that's the reason. So So that's the only drawback, but the benefits, in my opinion, are
So my understanding then is that to add a new extension, it's mounted in a different place. And
exactly.
because for every single extension is its own mount, you have to add it to both those
Yeah.
gucks.
Yeah.
And at least one of them requires a restart.
Yeah. But then, for example, we've had this conversation at EDB, for example, we're planning to have kind of flavors of predefined extensions. So, for example, you can choose a flavor and we distribute those extensions. So, for example, I don't know, for AI, we place some AI kind of extensions in the same image. So it would be different. But otherwise, I'm considering the most extreme case of one extension, one container image, which in my opinion for the open source world is the way that hopefully will happen. Because this way, think about that. I haven't mentioned this. If I write an extension, I can then build the image and then run automated tests using Kubernetes to test my extension in GitHub. And if those tests fail, my commit will never be merged on main. So this is trunk development. So continuous delivery. So this is, in my opinion, far better way of delivering and developing software. And this is again the reason why we ended up in Kubernetes. It's not because it's a technology we like, it's our toy or so, it's because it solves bigger problems than database problems. And then even when we talk about databases, there's still work that needs to be done, needs to be improved. And I'm really happy that we have more people that know Postgres nowadays that are joining CloudNativePg and are elevating the discussions more and more on the database level. Because before it was primarily on Kubernetes level, but now we see, Postgres, people that know Postgres better than me that get on in CloudNativePg and propose new ideas, which is great, which is the way it needs to be, in my opinion. Okay. So, but I remember, the Tembo approach because we actually talked a lot with them, Jonathan, Marco, I'm sure that you recall, when they were evaluating different operators and they chose CloudNativePg despite, I remember we had kind of, when these discussions where, they asked us to break immutability and we said no, immutability, we said no way, there's no way we can do that. And that's why I think Tembo had to do the solution you described because we didn't want to do it upstream. Yeah. But I think to be honest and to be fair, if image volumes were not added, we would have probably gone down that path because this way of managing extensions, as I was saying, is not scalable, the current one. Okay, so because we want to always improve, this is, I think, the approach we need to have, be critical on what we do. So I don't know, Niccolò, Marco, I would like you to, if you want, explain briefly.
Niccolò is the best one here because
yeah.
Yeah, you're always silent, Niccolò, but you deserve it.
All right. Do you want me to talk about the pilot or what we
Yeah. And then,
Sure. So
or even probably, I think the way you build images, I think that's probably the most interesting also. A very interesting, thing I think we could show, in my opinion.
yeah.
I can go to the patch if you want.
I can link you.
So I remember you forked, for example, PG Vector, if I remember correctly.
Yeah, I just linked that in chat if you see that. If you can open it on the
Yep. Can you see?
yeah, that's what we can do basically for every simple extensions that we can just build. This is a bit more complicated because we have to build from a trunk version of Postgres 18, so we have to compile pgvector from source. And then in a Scratch layer, we just archive the libraries and every other content that was previously built. But ideally, whenever like PG18 comes out as a standard version, as a stable version of Postgres, we just need to apt install pgvector and grab the files from
Yep.
the path. Where it gets a bit more tricky is in the case of PostGIS or TimescaleDB, or in general any extension that I mean whose library requires third-party libraries. So there is for example, PostGIS has a strong requirement on the geometric libraries. So you need to import them as well inside the mount volume. I can link you an example of the PostGIS one.
Yeah. So I think it's important. We've got, I think, Peter here, David as well. I mean, if you can, for example, if we could get standard ways in Postgres to generate Docker files for extensions, that could be, great. And as I said, this extension can be used by any operator in
Yeah,
Kubernetes. It's not CMPG.
that's what my
Here,
POC I
yeah,
linked to earlier does. And actually, there's a patch against the PGXS that would build
Yeah,
a
exactly. I
trunk
remember.
image.
Yeah. So yeah, so this is the work that Nicolo had to do to make PostGIS work in the pilot project. So he had to copy everything.
yeah. This is whenever. I mean, if we make this production ready, I think we can, of course, like make it a little bit smoother and like dynamically figure out everything from the from the um, from the PostGIS library, so that we don't have to hard code everything like this. But this is just a proof of concept that it can work.
So you installed all those shared libraries that were from packages. You just put
They are
them in the
installed
lib.
in the yeah, they are being copied inside the same mount volume where the actual extensions
Yeah.
are copied as well, and then the pilot patch has um, is able to set up the LD library path inside the pod so that it makes the libraries available to the system. Because of course these libraries are only part of the mount volume; they're not injected inside the system libraries of the pod. So we have to set up the LD library path to make them available to Postgres. That's how we're able to use them.
So
I
they
don't know
end
if
up
that
in
makes sense.
package lib. They end up in package lib dirt, but they still work.
Yeah,
That's nice.
But I mean, this is all. I mean, if there's better ideas, better ways. I mean, this was, as Nick also said, it was a proof
yeah.
of concept.
Yeah, I
Uh,
mean, probably a lot of these shared libraries could be shared with other extensions. So you might actually want
exactly.
other OCI images that just have some of the libraries that are shared
Exactly.
between. Yeah.
Absolutely. Yeah.
Exactly. So we could work on, special kind of extensions or even metadata that we can place, uh, so yeah, let's see. Anything else?
Yeah. Hello. I think it's important to invite everyone to try and test this, especially the Postgres trunk containers, when they want to try something new, stuff new like this one. Just because we always need people testing. When more people test and review and test and review, it's amazing because every time we release something, probably we will miss something, some extension like Post is missing one of the libraries that wasn't included in the path. Even if we can try to find a way to include it, it will not be there. So testing, please, ask all the time.
Well, we've got these actions now, they're failing. I mean, it's a bit embarrassing.
Yeah. No, it is fairly. We already have a patch to
Yeah.
fix it. Just
You
we
know,
need to
you know that when I
review it.
presented this once, it was the same. It was failing because of compilation issues.
But I mean, this is a great project, as I was mentioned before, because it allows us to test the current version of Postgres, but also if you want to build from a commit first, or if you've got your own Postgres repository with sources, you can compile, you can get the images from using this project. So anyway. I think I'm done.
Awesome. Right in time too. Unless anyone has anything else to share. David, did you want to share that spreadsheets once more for next week, or are you done gathering topics?
We're not done gathering topics, and I did not prepare for this. Here it is.
Sorry, I should have probably.
No,
Yeah,
no.
exactly.
So we're collecting topics for people would have an interest in talking about at the Extension Summit, which is Monday, May 13th at 8:30 a.m. in Montreal of PGConf. And Floor and Keith and Yuri and I are going to get together on Friday to kind of go through this list and pick out the things that have the most like emoji hearts next to them as likely candidates. And when we get there, on Monday, we're going to put up big post-its on the walls with the topics, and we can kind of summarize each one and figure out what we want to, which ones have the most interest, that have somebody who's willing to facilitate them, and then we'll break out into sessions to talk about them, either 2 or 3 separate tracks, or sessions, and however many tracks we need for each topic. So that's the plan. There'll be more details there on Monday. So please, if there's stuff that you particularly want to talk about with extensions, and for me, all the discussion today, I have there are like 6 things that go into my mind of things I want to figure out. Anyway, please get them into that spreadsheet, and we'll, especially if you are willing to facilitate. Thank you.
Sounds great. I think Yuri is still with the hand up, and Gabriele forgot to say something. So let's go. Yuri first.
Yeah, just a quick note. I think, David, you meant Tuesday for the
Yes,
summit part.
sorry.
Not Monday. Monday is PGX, where we'll also obviously seek input for what else can we talk about on Tuesday. But yeah, the summit is on Tuesday, PGX day, or on Monday.
Thank you for the correction.
Gabriele, do you want to right your wrong about not talking about SBOMs?
Yeah. I wanted to mention that I forgot to mention software billing of materials. That's very important. That's kind of now basic for any container image, and there's also the possibility to add them to these container images too. This is very important again in for change management, for security, and all of that in general, supply chain. Okay, and signatures too. But we've got signature for packages as well. I think SBOMs are interesting too. There's also attestation of provenance. So again, yeah.
Very good. All right. Well, then thanks everyone for joining this one and joining all the previous ones. And see you in Montreal.
Yeah, enjoy Montreal. Okay.
Oh, you won't be there?
No, I won't.
Oh, good. Well, I'm glad we had this then. It's been great. Thank you.
Thank you. Bye-bye.
Thank you.